Hello everyone, welcome to ZO 369, the energy of physics. Now we will discuss about the thermal expansions of solids in real life example. The question is why the gaps are left between the two iron rails in a railway track. Okay? The question itself it indicates. This is the best example for the thermal expansion of the solids. You can see here why the gaps are left between the two iron rails in a railway track. So imagine this is in this figure. This is the railway track made with iron, a strong alloy, and here the gap should be left between here. This is the gap should be small gap should be left between the two rails. Here this gap, not this gap, and here also some small gap is there. So why the gap is left between them? Because in summer we can see here in summer the temperature is more. We can write it here more. Means in normal room temperature this is 35 degrees Celsius. In summer what will happen? It has to be sometimes it has to be 45 degrees Celsius temperature. So what is the temperature difference in this case? Temperature difference is 45 minus 35 minus 10 degrees Celsius. But for every 1 degree Celsius raise in temperature, this material will be expands. If it expands, what will happen? It becomes buckling. So that what will happen? It expands. If it expands, the gap is will be covered and uneven. During the summer, the temperature rises from 35 degrees Celsius to 45 degrees Celsius into full hot summer. So for every rise of 1 degree Celsius temperature, this iron material will be expands. So if it expands, what will happen? This gap should be covered and it will be not in equal way. So it will be buckling like this. So that if the gap is left during the summer, it can be covered. So this is the best example for why the gaps are left between the two iron rails, particularly in the case of summer only. If it is winter, what will happen? If it is winter, what will happen? So this gap should be slightly increases because of in winter, what will happen? The temperature will be less. So for every raise of 1 degree Celsius temperature, it will expand. For every decrement of 1 degree Celsius temperature, it will be contract. So to avoid this one, so the gap should be left between the two rails. Next, most important questions. Why does a blacksmith heat a metal rim made with iron before fixing it onto a wooden cart wheel? Okay, so now we can see in this figure, this is the wooden cart wheel and this one is the iron rim. So both of them are the manufacturer, the blacksmith made with both the same diameter. But for iron rim, the diameter is slightly smaller than the wooden cartwheel. Then how do this rim can fix it onto the wooden cartwheel to make it tightly bonding? So for this purpose, what he will do, this is the iron rim, no? So when heat is heating, means on heating on heating the iron rim, what will happen? It will be expand. It will be expand. So if it expands, what will happen? Its diameter is slightly more than the wooden diameter of the wooden cartwheel. So immediately what will happen? This iron rim is fixed onto the wooden cartwheel, and then it cools. It cools. Then what will happen? It is tightly fixed. It is tightly fixed. Do you remember? The simple answer is even though the iron rim and the wooden cart will have the same diameter, when it is the iron rim is heated, on heating it will be expands. So immediately this iron rim is fixed onto the wooden cart wheel and then cools. If it cools, what will happen? It contracts. So it is firmly fixed onto this. But that's why a blacksmith heat a metal limb before fixing it onto a wooden carpet. This is the answer. In the question itself, we can write the conclusion. That's it. Next real life example. Why are the electrical wires loosely stretched? Means sag between the two poles, especially in winter. This is the question. So this is also be based on the application of the thermal expansions of solids. Now we can see in this figure, there are the two cement poles will be there, and these are the electrical wires which is made with copper or aluminium. And between these two poles, the electrical wires are loosely stretched, particularly in the winter. So what will happen? If it is tightly fixed, what will happen? If it is loosely stretched, what will happen? We can see in the winter, temperature will be decreases. Temperature will be decreases. So we can write this is decreases. In general, room temperature is 37 degrees Celsius. Human body temperature also we can consider. In winter, what will happen? The temperature is almost 10 degrees Celsius or 15 degrees Celsius, whatever it may be. This metal wire is there, no? This metal, what is the nature of the metal? For every raise of 1 degree Celsius temperature, it will be expands. For every decrement of the 1 degree Celsius temperature, this metal wire will be contract. So in the winter season, what will happen? If it is loosely stretched, the temperature will be less so that it will be contract. So it will be contract so that it will become tight. That's why the electrical wires are loosely stretched between the two poles, particularly in the case of winter. In winter means remember the temperature is decreases, so the metal wire will be contract. That's why these are the loosely stretched. Okay. The next one more best example. Why the pendulum clocks made with metal rods run fast in the winter and run slow in summer? This is one question important for 4 marks. Or else sometimes why the pendulum clocks gains the time in winter and lose the time in summer. The question, however, they can ask, but the answer is the same. Explanation is the same. Now we'll consider in this case the pendulum clocks. Pendulum clock. It is made with metal rod. Made with metal rod. Metal means it is the solid material, no? On heating, what will happen? The length will be increases. On cooling, what will happen? The length will be decreases. In this case, we can write it here. Two different cases we can see here. First, in winter, we can take winter. Another one is the summer. Two different scenarios we can consider how the pendulum clock shows the time. In winter, we can write temperature is decreases. In summer, the temperature is increases. Increases. Okay. The pendulum clock. Here one formula we can remember. The time period of the simple pendulum T is equals to 2 pi under root of L by G. Already we have studied, we have discussed in oscillation chapter. So on what factors the time period depends? T is proportional to L, root L. The time period of the simple pendulum or pendulum clock made with metal rod, whatever it may be, it depends only on the length of the pendulum. If the length increases, the time period increases. If the length decreases, time period decreases. On what factor the length increases or decreases depends. It depends upon the temperature of the surroundings. So in winter, the temperature is decreases. Means for every 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, it will be decreases. So that what will happen in this case, length will be contracts. Length will be contracts because it is the metal. In the case of summer, what will happen? The length will be expands. Length will be expand for every rise of 1 degree Celsius temperature. If the length is contracts, length decreases, in this case, the time period is also be decreases. Here I am writing decreases. Time period also be decreases. In summer, the time period is increases. These are three important points we can remember. Here, don't be confused T and T. One is the temperature, another one is the time period. What is time period? Time period is the time taken to complete one oscillation. We can say time period. So in winter, what will happen? The time period is decreases. Time period is decreases means it moves very fast. Time period is elongated, prolonged. What will happen? The time taken to complete one oscillation is increases. When will it happen? Increases means in the case of summer. Now we will discuss about the why the pendulum clocks run fast in the winter and run slow in summer. So the simple answer is pendulum clocks are made with metal rods. The time period of the any simple pendulum or any pendulum clock depends on t equals to 2 pi under root of L by G, means t is proportional to L. Means the time period depends only on the length of the pendulum clock. So in different two scenarios, in winter first we will discuss about what will happen. In winter, the temperature will be decreases. For every 1 degree Celsius temperature decreases, the length will be contract. So when the length will be contract, the time period is also be decreases. What is time period? Time period means the time taken to complete one oscillation. Time taken to complete one oscillation. This decreases. Means in this case, what will happen? The pendulum clocks runs fast. In which case, this is a winter. It runs fast so that what will happen? It gains the time. It gains the time. This is only about the pendulum clocks in the case of winter. In the next scenario, if it is in summer, what will happen? In summer, the temperature is increases. If the temperature increases, then what will happen? Length is also be increases, means length will be expands. If the length increases, the time period is also be what will happen? Increases. Time period increases means the time taken to complete one oscillation is increases, means it moves very slow. That's why we can write it here. It's slow run. It runs slowly. Slowly it runs. Slowly it runs, what will happen? It lose the time. It lose the time. So this is the two different scenarios of the pendulum clocks. So we will come to one conclusion. If in winter it's move fast and in summer it moves slowly, and we cannot expect the correct time. So to get the correct time, these pendulum clocks are made with some particular alloy. That metal is invar steel. That metal name is invar steel. For invar steel, if it is made with invar steel, what will happen? Even the temperature increases or decreases, it will not be expand or contract. Means it's the coefficient of linear expansion of the invar steel is zero. That's why the measuring tapes and the pendulum clocks all are made with invar steels. Now, one more example we can discuss. Why the platinum was traditionally used to seal the glass. Here, three materials: glass, platinum, to seal it. Why? Examples in the case of electric bulb or vacuum tube. Okay, we can see here glass. Glass is also a solid material, and a platinum wire. This is also a solid material. On heating, the glass will be expand. On heating, platinum will also be expand. On cooling, glass will be contract. The platinum is also be contract. If the glass and platinum, the alpha glass is equals to alpha platinum, the coefficient of linear expansion of the glass material and the coefficient of linear expansion of the platinum, both are almost equal. Both are almost equal. That's why what will happen during the summer, if it expands, this also be expand with the same dimension, same magnitude. In the winter, if it contracts, and this also be contract with the same magnitude. That's why the platinum was traditionally used to seal the glass, particularly in the case of electric bulb and vacuum. Why the glass breaks when it is poured with the hot water, or whenever the hot water is sprinkled on the glass plate, it will be breaks. Why? It's a very simple. When the hot water is sprinkled on the glass plate, what will happen? It will be expand and the glass will be contact. So due to the uneven contraction and expansion, what will happen? The stress will be increases, so that the glass plate will be cracks or breaks. Next, most important question: thermostat bimetallic strip. First, we will see that what is bimetallic strip. Bimetallic strip is it consists of the two different metal wires or metal plates of the same area, same size. So one upon it is riveted to each other. So in this case, we can see here the copper and steel. These are the two different metals of the same area, same size, same dimensions, and it is fixed one over the other one. So simply we can say this is the bimetallic strip. Here the two different materials, so that their alpha, the coefficient of linear expansion of the copper and the coefficient of linear expansion of the steel, these two will also be different. For example, if alpha copper is more than the alpha steel. Example, this is alpha value is 0.0018, and this one is 0.0012. Imagine like this. Which one is more? This one is the more. Today we'll discuss about the bimetallic strip and thermostat. This is most important question for 4 marks. Bimetallic strip. Bimetallic strip consists of the two metal sheets with the different coefficient of linear expansions, but the same size, same dimensions, and riveted with one over the another one. So like this. Here the copper and steel. These are the two metal strips. So fixed one over the other one. In this case, we can see different metals will have the different coefficient of linear expansions. Means those metals will respond depending upon the temperature. If the temperature is increases, the metal wire which has more coefficient of linear expansion, it will expand more compared to the another one. In this case, we can see at room temperature, the copper and steel bimetal strip will be like this. On heating, what will happen? So here alpha copper is more than alpha steel. So that here copper expands more. Copper expands more than steel. Copper expands more than steel on heating. Here on cooling, what will happen? The copper, do not confuse here, the copper contracts more than steel. Here the word is important, expands and contracts. Means in this scenario, what we have to observe is any metal wire which has more coefficient of linear expansion, on heating it will expand more, on cooling it will contract more. So in this case, the bimetallic strips on heating, it will be expands more and it will contract more. And these ends are connected to the switch wire. This is connected to the switch wire. Means this thermostat means here, it is the temperature controlled material, like automatic iron box which we can use in the house, domestic purpose. In this iron, what will happen? It automatically, when the temperature rises, what will happen? It will automatically stop and cool stop. You understand here? This is the basic thing. These thermostats are used in uh, automatic iron boxes and refrigerators, refrigerators to control the temperature of the appliances. This is one main advantages of the bimetallic strip which are used in the thermostat. For watching, like, share and subscribe my channel Zo 369. The energy of physics. Stay curious, stay energetic.